Assalamu alaikum. My name is Kibria.
I'm Ahmed Farouk.
And I'm Sarmad Sultan.
And today we would like to talk about a cloud-based network management system known as Cisco Meraki. Before talking about Cisco Meraki, it is important to understand and discuss the following. First, what is a network? A network is a connection of computers, devices, servers, mainframe network devices, and any other devices connected to one another. Let's look at the example of two friends chatting with one another over Facebook. In order for this communication to take place, data has to be transmitted over the internet between the two users. More specifically, through a path consisting of several nodes and links such as switches, routers, and gateways over either physical lines such as optical fiber or through satellite. Secondly, we need to understand what is network management. Network management refers to the processes, tools, and application used to administrate, operate, and maintain a network infrastructure. Let's look at the example of FAST University. The university's network includes labs with a number of computers connected to each other as well as connected to the internet. This network relies on servers, routers, and switches. This whole network is managed by FAST's IT department, which is responsible for monitoring the network connection, solving problems in the network, and monitoring traffic on the network. Imagine you're a business owner with multiple work sites all over the country. Each work site has multiple computers connected to each other that require communication with other work sites to maintain and manage critical workflows. If a single computer or server goes down, it could cause heavy losses in revenue and a host of other problems, which is why it is crucial that network management frameworks are utilized to identify and solve problems within a network quickly and efficiently.
How are networks managed? Network management system. Network element vendors make their performance data available to NMS software either through APIs or through a protocol such as NetFlow, a de facto industry standard originally developed by Cisco that allows NetFlow enabled routers to transmit traffic and performance information. Network engineers use a network management system to handle a variety of operations, among them monitor performance by collecting operating metrics through a series of physical taps, software agents, or simple network management protocol interfaces. An NMS can provide the visibility necessary to determine if network elements are operating correctly. Detect devices. A network management system is used to detect devices on the network and to ensure the devices are recognized and configured correctly. Analyze performance. An NMS is used to track performance data indicators, including bandwidth utilization, packet loss, latency, availability and uptime of routers, switches, and other network components. Enable notifications. In the event of a system disruption, an NMS will proactively alert administrators about any performance issues. Another tool you can look into is called IP Address Manager, IPAM for short, which helps to ensure the IP addresses on your network are set up and allocated correctly. Cloud computing and network management. Enterprises are increasingly adopting and relying on cloud services and tools to monitor and manage their networks. Generally, cloud adoption often adds to a level of complexity to network monitoring because moving applications out of the internal data center influences how network administrators track performance, latency, and other key details. In traditional network implementation, network and application monitoring primarily focuses on the availability and performance of the network and server infrastructure. Monitoring of network devices, routers, switches, and firewalls is usually accomplished with a network management system, NMS, that uses a traditional protocols such as SNMP, ICMP, and WMI to gather performance statistics. Advanced management systems typically include network device discovery and mapping, network device performance monitoring, real time intelligent alerting and reporting, application monitoring, and many more features that assist the IT expert in monitoring and managing the performance of their network. Once a cloud network is introduced, additional significant extensions are added. The performance of your ISP, WAN performance, and the performance of your cloud provider and their ISP, since your WAN link is the essence between you and your cloud provider, it is imperative that you monitor its performance. However, it's not enough to simply monitor WAN performance. You also need to understand your network traffic in order to assess the impact on the performance of business critical apps and services. You need to know who is using your network traffic, how much they are using, and what they're using it for. Basically, the focus of network monitoring in a cloud environment shifts away from managing infrastructure to managing service availability and performance. So, one of the big benefits of cloud computing is not only outsourcing the provision of a scalable enterprise grade network, but also necessity to monitor and manage it as well. A brief introduction to Cisco Meraki. The Meraki Cloud Solution is a centralized management service that allows users to manage all of their Meraki network devices via a single, simple, and secure platform. Users are able to deploy, monitor, and configure their Meraki devices via the Meraki dashboard, web interface, or via APIs. Once a user makes a configuration change, the change request is sent to the Meraki cloud and is then pushed from the Meraki cloud to the relevant devices.
Now that we understand what a network is, why network management is important, and how networks are managed, let's take a look into one of the industry leaders for cloud-based network management solutions, Cisco Meraki. The Meraki cloud is the backbone of the Meraki management solution. This cloud is a collection of highly reliable multi-tenant servers strategically distributed around the world at Meraki data centers. The servers at these data centers are powerful hosting computers comprised of many separate user accounts. These servers are called multi-tenant servers because the accounts all share equal computing resources on their host. However, even though these accounts share resources, Meraki ensures that customer information is kept secure by restricting organization access based on account authentication, as well as hashing authentication information such as user passwords or APIs. Within the Meraki data center, customer management data is replicated across independent same region data centers in real time. These same data is also replicated in automatic nightly archival backups hosted in-region third-party cloud storage services. The Meraki cloud does not store any customer user data. All Meraki services, the dashboard and APIs are also replicated across multiple independent data centers so they can fail over rapidly in the event of a catastrophic data center failure. These data centers hold certifications such as PCI, SAS70 Type 2, SSAE, PCI, and ISO 27001. Additionally, all Meraki data centers undergo daily penetration testing by an independent third party. More key data center features include 99.99% uptime service level agreement, 24/7 automated failure detection, real-time replication of data between data centers, all sensitive data, all sensitive data, for example, passwords, are hashed on servers. Meraki uses an event-driven remote procedure call RPC engine for Meraki devices to communicate to the Meraki dashboard and for Meraki servers to send and receive data. Meraki hardware devices act as the server receiver as the Meraki cloud initiates calls to the devices for data collection and configuration deployment. Because the cloud infrastructure is the initiator, configurations can be executed in the cloud before the devices are online or even physically deployed. In the event of cloud connectivity loss, which is most caused by a local ISP or connection failure, the Meraki hardware device will continue to run with its last known configuration until cloud connectivity is restored. Device configurations are stored as a container in the Meraki backend. When the device configuration is changed by an account administrator via the dashboard or API, the container is updated, then pushed to the device the container is associated to via a secure connection. The container also updates the Meraki cloud with this configuration change for failover and redundancy. In this diagram, we can see how this process is carried out. An IT admin enters a command in the Meraki dashboard. The organization server receives the information from the user. The server calls the device to update the device configuration. The Meraki device receives a config update and updates its local configuration. The server sends the changes made to its region. And finally, the Meraki cloud receives new configuration data and updates its regional records. For security purposes and for devices to communicate with the cloud, Meraki leverages a proprietary lightweight encrypted tunnel using AES 256 encryption while management data is in transit. Within the tunnel itself, Meraki leverages HTTPS and protocol buffers for a secure and efficient solution, limited to 1 kilobyte per second per device when the device is not actively managed. The most crucial part about the Meraki interface is the Meraki dashboard. The Meraki dashboard is the visual alternative to traditional command line, which is used to manage many routers, switches, security devices, and more. Instead, Meraki puts all devices within networks in one place and allows users to apply changes in a simple, easy-to-use format. In addition to simplifying device management, the dashboard is also a platform for viewing network analytics, applying network permissions, keeping track of users, viewing camera streams, managing users' mobile devices and computers, setting content rules, and monitoring upstream connections. Meraki APIs provide control of the Meraki solution in a programmable way, enabling actions that may not be possible with the dashboard or providing more granular control. Meraki APIs are RESTful APIs using HTTPS for transport and JSON for object serialization. By providing open API accessibility, Meraki leverages the power of the cloud platform on a deeper level to create more efficient and powerful solutions. Through Meraki APIs, users can automate deployments, monitor their networks, and build additional solutions on top of the Meraki dashboard. Now, let's take a quick look at the Meraki family of devices. First off, we have the Meraki wireless access point. These access point features bring your own device policies, application traffic shaping, guest access, enterprise security, and location analytics. They also are available in 5 models for indoor-outdoor usage, and also for enterprise-class silicone, including RF optimization, PoE, voice and video support. These devices also come with a lifetime warranty for the indoor access points. Another important part of this family is the Meraki security appliances. These appliances have a zero-touch site-to-site VPN, WAN optimization, an NG firewall, content filtering, WAN link bonding, and intrusion detection. And these have 6 models depending on your requirements, your size of organization, etc. We also have the Meraki access switches, which feature voice and video QoS, layer 7 app visibility, virtual stacking, power on Ethernet on all ports, and remote packet capture cable testing. These switches are available in a variety of configurations, again, depending on the use case and type of organization. Another important member of this family is the Systems Manager Mobile Device Management, which uses centralized app deployment, device security, rapid provisioning, backpack file sharing, and asset management. The cool thing about this is that this device management works across operating systems such as iOS, Android, Mac, and Windows devices. To conclude this presentation, it is important to mention that the reason cloud-based network management solutions are so powerful and so in demand is because the world is moving slowly away from the idea of building data centers for every business. Data centers can be hard to build and manage. If this data space can be subscribed to from a reliable service like Cisco Meraki and all the others, then there is no longer a need for you to invest money into building your own data centers. And as such, solutions like Cisco Meraki provide very powerful tools for managing your network, shaping traffic, and getting useful analytics that can help you improve your business or your customer service.